So in these examples, we're going to be combining some transformations. Here we have our f of x defined, not as some algebraic computation, but as some pattern, okay, and just as a picture. And so we're going to transform this picture. So to do this, first of all, we want to define the function, and we want to have our input and outputs that we want to track, or our reference points. Okay, so I'm going to choose some reference points here. The most obvious ones are going to be the endpoints and the vertices. Okay, so these are going to be the points of reference. These are the points that we're going to track to do our transformation. So our original coordinates are going to look like this. Okay, so these are original coordinates. So we're going to have -7 and -2. It looks like -3, +6. Okay, this one looks like 0, 2. Okay, that's our middle point. 3/6 up. Okay, and the symmetrical point here is going to be negative or +7, -2. Okay, so we're going to start with the y transformations because the y transformations tend to be a little bit easier. So I'm just going to do the change in y first. So the change in y is going to be, I'm going to take a vertical translation down 2. So I'm going to do -2 first, and then I'm going to flip afterwards. Okay, so now algebraically, this would be the same as if I got rid of the brackets and said flip first, right, or up 2. Okay, so since the y's are fairly straightforward, I'm going to actually show my function notation as well. Okay, so there's my f of x. Okay, so here's my f of x. Just going to leave some space for my inside transformation. Okay, and then -2 first. So I need brackets and then flip afterwards. Okay, so then doing my table of values here, my new y coordinates, I'm going to apply that transformation. So -2 flip, so I'm going to end up at 4. -2 flip, so that's going to be -4. -2 flip, that'll be 0. -2 flip, -4, -2 flip, I'm going to be at +4. Okay, so those are my y transformations. Those are pretty straightforward. Okay, so then I need to do my x transformations. So my x transformations, the order is going to matter. So I'm going to write my change in x, and I'm going to transform my coordinates first before I do the notation, because the only time I need to do backwards is when I go from my description, all my tables, my graphs, my word descriptions to the notation, or from the notation to the other ones. Okay, so that's the only backwards part of it. So I'm just going to write my change in x algebraically. This is my description, or my do part of it. I'm going to do this. I'm going to go to the right first. Okay, so I'm going to go +1. I'm going to flip it horizontally second. Okay, so I need brackets, and then I'm going to compress by 1/2, so I'm going to divide by 2. Okay, so this is what's going to actually happen. So this is what I'm going to use to transform the coordinates. Okay, so I'm going to add 1, flip, so it's going to be +6, divided by 2, so +3. -3 plus 1 is -2, flip is going to be +2, divided by 2 is 1. 0 is going to be -1/2. 3 plus 1, flip is -4, divided by 2 is -2. 7 plus 1 is 8, -8 divided by 2 is -4. So those are all my x transformations. Okay, and I used exactly what was written here. I expressed it algebraically. I used this equation to calculate new coordinates. Okay, so when I actually draw my graph, again, nothing's done backwards yet. I haven't done any backwards because all this is just all consistent with each other. So when I draw this new graph, okay, my new coordinates are going to be at 3/4 up, okay, 1/, -4 down, -1/2, 0. Okay, now that happens to be my my middle point, -2, -4, -4, +4, it's right there. Okay, so now I have my M shape has been vertically flipped, so it's a W shape. Okay, it's been shifted down, it's been horizontally compressed. Okay, it's got a horizontal flip, which actually doesn't do anything to this because the horizontal flip really is just going to make it look like a W anyways. So there's my translated function. So I've done all my transformations now. The only thing left then is my notation. And I have to, this is where the reverse comes in. I have to do the opposite. Okay, so my notation, I'm going to undo this. So I'm going to times by -2 first, and then I'm going to subtract 1. And I'm just basically solving this expression for the other x. So this becomes my notation. This is what I'm going to use in my function notation. I've undone all the algebra here, so this is what I'm going to use. So I'm going to plug in -2x minus 1. Now you could put it in factor form if you like, doesn't matter. This I've just undone algebraically, so whatever form of this expression you want to use is going to be good enough. Okay, so there is what I'm going to leave it as. There's other variations of this which would be perfectly acceptable, but it's the opposite of what I actually did. Okay, so this next one we're going to do the same thing. Okay, but we want to have some reference points, so I'm going to need to establish my original f of x. Okay, so I want to have some reference points here, here, here at all the vertices, and probably should have one down there. So I'm going to go from left here, so it's going to be -6, 0, -3, +3, 0, +6, okay, 3/3 up. Actually, I should probably put that other, actually I'm going to do that. And this is going to be 6/0 up, and then I have 0, -6. Okay, so that represents the bottom point. Okay, so those are my coordinates, my starting point coordinates. I got to separate my vertical transformations from my horizontal, but I also have an inverse. Okay, now the inverse technically can be done at any point, but as soon as I do an inverse, all my verticals become horizontal, all my horizontals become vertical. So in this case here, it's probably easiest to just follow this transformation and then do the inverse last. Okay, the inverse involves just switching x and y coordinates. So we're going to do 3 parts here. I'm going to do our horizontal. Okay, we're going to do all our vertical. All our vertical. Okay, and then our inverse is going to be done totally separately. Okay, so the inverse is going to be done independent. It doesn't really affect this except other than once I do an inverse, vertical switches to horizontal, horizontal switches to vertical. Okay, so let's do our first part here. Let's start with the vertical. Usually that's easier, so we'll do that first. Okay, so my vertical translation, I'm going to get up by 2, so +2. I'm going to flip it and compress it. Okay, so there's my vertical transformation. So I'm going to make my new table here. Okay, this is before I do my inverse. Okay, so I'm going to apply this transformation. So I'm going to apply that transformation +2 times -1/2. So that's going to be -1 +2 times -1/2 +2 times -1/2. It's going to be -4 +2 times -1/2. Okay, +2 times -1/2. So it's going to be -1. And that point there is going to be +2 -1/2 is going to be, so it's going to be -4 so it should be positive 2. Okay, so there we go. That's the last coordinate there. Okay, the horizontal, pretty straightforward. There's only one step. Okay, it's going left 1, so I'm going to go minus 1, minus 1, minus 1, minus 1, minus 1, minus 1. Okay, so the change in x is going to be x minus 1. Okay, and this is my description, so I need to undo this once I put it into my notation. Okay, oops, so it's going to be the other way around. It's going to be x minus 1. Okay, so I'm going to undo this to put into my notation. So I'm not going to bother doing that yet. I'm going to do my transformation first. So I'm going to do the last transformation here, which is going to be my inverse. So my inverse then is going to involve switching my x and y. So all my y's become x's, and all my x's become y's. So negative 1, negative 2.5, negative 4, negative 2.5, negative 1, negative or positive 2. So those are all my new x's. My x's now become y's. So negative 7, negative 4, negative 1, 2, 5, negative 1. Okay, so now I've applied all my transformations. I'm going to draw the picture first, then I'm going to worry about the notation. Notice again, I've not done anything backwards. Everything that's been described to me is exactly what should happen. And again, notice that I did the inverse last to make it much easier for myself. So, drawing in these coordinates, negative 1, negative 7, give me that point there, negative 2.5, negative 4, maybe right about there, okay, negative 4, negative 1, negative 2.5, positive 2, so it's going to be there, negative 1, positive 5, it's going to be there, and then 2 over negative 1. So this represents the bottom of the circle there, and have straight lines here and here. This represents the dome, the bubble part. Okay, so there it is. There's my transformation. I've done my vertical, horizontal, and then I did the inverse. So notice that instead of pointing up, the pointing along the y-axis like this, is now pointing along the x-axis like this because x and y's have switched. Okay, I'm almost done. The last thing I need to do is put it into function notation. Okay, so here I'm going to have my function notation should be 1/2 y, oops, my f of x, I should write it as f of x, f of x, okay, plus 2, bracket, okay, so it's going to look like that. And the inside part of that, well, this is now where I have to do backwards. I have to undo that expression. So I'm going to undo this expression, x plus 1. That's what's going to show up in my notation. Okay, so it's going to be x plus 1. Okay, so the last thing is I need to do my inverse. So I need to switch my x and y. So my x and y switch. So that becomes x, and this becomes y. So I've now applied my inverse. Now I can't actually solve for this because I don't have an equation to undo this. So I'm going to have to leave my inverse in this form with my f of y form. So just writing out the final, what it should look like. It should be x equals 1/2 f of y plus 1 plus 2 and brackets there. Okay, so there's my final transformation.